Alright, welcome to the video. This one is going to explain to you how to find the roots or convert a quadratic into factored form. So before we tried to just factor the equation, but sometimes the equation is either not factorable at all, or it's not factorable using simple whole numbers. And so if you try to factor it into the brackets and that doesn't work, you can't simply find two numbers that multiply to the last value and add to the middle value, or do the guess and check or factor and cancel or anything like that. Then the quadratic formula is going to be kind of your safety net that you can use to find the roots for any parabola. So our idea is you would start with an equation in standard form, y equals ax squared plus bx plus c. And if you complete the square on that, to find the roots you'd set y equal to 0. So you're going to start with your standard form, y equals ax squared plus bx plus c. If you complete the square on this, if you know the values of a, b, and c, you've learned how to complete the square. And you go through and you take half the middle value squared, you get your perfect square. Then you can write the equation in vertex form. So once you have an equation in vertex form, if you set the y value equal to 0, you can work backwards and solve and branch and take the square root and get the two roots, and then you can write the equation in factored form. So ultimately we're going to be getting the two roots, which will enable us to write the equation in factored form. But instead of applying it to a specific example like we've been doing with complete the square, we're going to apply this technique to the general form y equals ax squared plus bx plus c. So we're going to be doing a lot of math and manipulation with variables because we've got a, b, and c that are going to get moved all around. But the formula that we get at the end is going to be worth it, because then once you have the formula, you kind of never have to complete the square again. You can just go straight to the answer. Right here is super important and super useful. This is called the quadratic formula. Okay, so the formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where you remember that these are the roots. So what you're finding here are the roots, or the x-intercepts of your parabola, and the a, b, and c in this formula are from standard form. So this only works if you set your equation up in standard form. If you do have your equation in standard form, then you can look at it and you can figure out what your a, b, and c values are, and then you can plug them directly into this formula without having to complete the square, without having to add or subtract things from both sides. You just plug them straight into this formula and it will give you out the roots. The reason it works is because we went through all the same steps that we would have gone through with numbers, but instead we went through those steps with variables, which means it's going to work for anything that you plug in. Okay, so the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's take a quick couple of examples to plug in numbers and see how it pans out, and then we'll almost be finished. So what if your example is y equals simple one, x squared plus 6x plus 8. Now I know you could probably look at this and say, oh, I think I could factor that, and you could, but let's try solving it with a quadratic formula just to see that it works on things that we think it should work on. So let me identify my a value, my b value, and my c value. The first thing I like to do is write down what these numbers are. So a is 1, b is 6, and c is 8. Now let's write down the formula. It's always good to write down the formula before you start plugging in. So negative b plus or minus the square root of b squared minus 4ac. I also encourage you to say it out loud to yourself whenever you're writing it down, because if you say it out loud, it will help you remember it. All divided by 2a. So now we can plug in our numbers. Negative b is negative 6 plus or minus the square root. B squared is 6 squared, so that's 36, minus 4ac. That's 4 times 1 times 8. What is 4 times 1 times 8? 4 times 1 is 4, and that times 8 is 32. So we can put that there. All divided by 2a, that's 2 times 1, which is 2. Now we have this equation, we need to simplify it. So what's 36 minus 32? That's going to be a 4. So we have negative 6 plus or minus the square root of 4, all divided by 2. And we can simplify the square root of 4 is 2. So negative 6 plus or minus 2 divided by 2. And now there's two possibilities, the positive and the negative. So negative 6 plus 2 is negative 4 divided by 2. Negative 4 divided by 2 is negative 2. The other option is negative 6 minus 2, which is negative 8, divided by 2 is negative 4. So negative 2 and negative 4 are the roots. The coordinate points would be negative 2, 0 or negative 4, 0. Now alternatively, we could have factored this and we could have gotten x plus 2 times x plus 4, and we could have seen right away that the roots are negative 2, negative 4. So the thing with the quadratic formula is you want to try to factor the expression first if you can, and only if you've tried to factor it and you can't get it should you resort to the quadratic formula. Because even though it works for everything, it does take a bit of time. And so if it's going to end up being an easy answer, it's usually simpler to just do it by factoring. But sometimes you can get problems that are not very easy to factor by hand. And in those cases, the quadratic formula is really valuable. So what if we had y equals 3x squared plus 2x minus 4. So you might start looking at this and thinking about it, and just by looking at it, well, it's got a 3 in the front, but none of these have a 3 in them, so you can't factor that out. So you might have to do some weird guess and check, and it's going to come out to be pretty nasty. But if you want, you can just write down a equals 3, b equals 2, and c equals negative 4, and we can start plugging in this formula. I won't write it again because I have it right here, but in general, if you don't have it written already on your paper, you should write it again. So negative b is negative 2 plus or minus the square root b squared, that's going to be 2 squared, which is 4, minus 4 times a is 3, and c is negative 4. Okay, so let's be careful here. All divided by 2a, which is 2 times 3, which is 6. So we'll write this again, equals negative 2 plus or minus. So here we have subtracting a negative, so that's going to become positive. 4 times 3 is 12, and 12 times 4 is 48. So that part's 48, and then we add 4 to get 52. Square root of 52, all divided by 6. Okay, now the square root of 52 can be simplified because 52 is breaking down into 13 times 4. So the square root of 52 is the square root of 13 times the square root of 4. And the square root of 4 is a perfect number, which is 2, with left behind the square root of 13. So if you don't remember how to do simplifying radicals, I encourage you to go back and take a look. So now we can write this as negative 2 plus or minus 2 root 13, all divided by 6. And we can see that the numerator both has a 2 and the denominator has a 6, so we can change this to a 1 and a 1 and a 3. Essentially, reduce everything by a factor of 2. So our final answer is negative 1 plus or minus the square root of 13, all divided by 3. So you can see that's probably not an answer you ever would have gotten by trying to factor this thing by hand, yet still it gives us the x values. So it's really very beneficial to finding the two roots of the parabola, which allows you to write it in the equation in factored form. And further, we'll learn in the next lesson that finding these two roots and using the quadratic formula can really be a boon to helping you find the x value of the vertex. So one last thing before we're finished, and that is called the discriminant. So there's a part of the quadratic formula that's called the discriminant, and it's actually this part that's under the radical. The b squared minus 4ac is called the discriminant. And the reason is because it discriminates between three different possibilities. So if you just look at this part, the square root of the b squared minus 4ac, in fact, you don't even need the square root. Really, you're just looking at the b squared minus the 4ac. That's the discriminant there. If it's positive, if just the b squared minus 4ac part is a positive number, there's going to be two roots, because when you take the square root, you have to branch and you get plus or minus. So if that part comes out positive, there's two roots. If this part comes out 0, well, the square root of 0 is just 0. There's no positive or negative, so there's only going to be one possible answer, which is the double root. And then if the part here, b squared minus 4ac, is negative, you can't take the square root of a negative, so that tells you there's going to be no roots at all, which, if you recall, how could a parabola have no roots? It could be above the axis opening upward, or it could be below the x-axis opening downward. So this would be examples with no roots, in which case the discriminant here is going to be a negative number, and you can't take the square root of a negative. So let me zoom back to the beginning just to remind you what we did. We started with the equation in standard form. We did completing the square with all variables to derive something called the quadratic formula, which is this big formula that you have written down in stars somewhere in your notes. And then finally we did a couple of examples showing that if you identify the values of a, b, and c, you can plug them into the quadratic formula and get out your answer. And it works on easy ones, but it also works on difficult ones. If you do have easy ones, I recommend you try to factor it, and then only use the quadratic formula if factoring doesn't work. And lastly, there's this piece b squared minus 4ac, which is called the discriminant, and that tells you how many roots there's going to be. Alright, we'll do a lot more examples in class, and take any questions you have with you and ask them then.